Hope all of us are doing great. My name is Ernest, and this Ernest Sciences and Mathematics TV channel. Today's discussion is basically the concept of Avogadro's law, and this, of course, is going to be a follow-up discussion from the last one we had on the Gay-Lussac's law for combining volumes. Now, from our previous discussion, we said that Gay-Lussac came up with a law that involved a chemical reaction of gases, whereby it stated that basically these chemical reactions are going to take place in ratios of small whole numbers. And we are given an example of the reaction between nitrogen. Of course, I'm going to give it. So there was an example that we had given on the reaction between nitrogen and hydrogen to give this ammonia. And then we see that this basically reaction is a gaseous reaction of the reactants and the products going to be formed as such. And this is going to give for us a basis of the relationship between or the stoichiometric relationship between various aspects of gaseous reactions. And in our discussions, we're going to consider the case of course, a mixture of gases and pure gases in general. Now that we had said that gases basically have got a general or somehow a similar kind of behavior whenever we're trying to talk about them, or various ranges of gases that we may come across. So in this case, in our last discussion, Avogadro had suggested that equal volumes of all gases at the same temperature and pressure are going to consist of the same number of molecules. And of course, as we said, it was the first one to distinguish between atoms and molecules in that specific case. And in this particular discussion, we're going to explore the relationship between the volume of a particular sample of a gas and the number of molecules. And of course, Avogadro's law states that basically the volume of a sample of a gas at a constant temperature and pressure, of course, is directly proportional to the number of molecules. And this is going to be given in terms of this specific ratio, whereby, as we said, at the constant pressure, temperature and pressure, the volume of a particular sample of a gas is directly proportional to the number of molecules given as such. So in this case, V represents the volume, T is the absolute temperature in kelvins and pressure given as such. Now we have said that basically we can have this particular relationship by looking at the volumes of gases which are going to be involved in a particular reaction. And of course we can therefore be able to calculate the number of molecules which are going to be involved in this particular type of reaction using this relationship of Avogadro's law. Therefore, the concept of Avogadro's law is going to give us a connection between properties of various gases and their stoichiometric forms in terms of chemical reactions using this particular symbol, of course, reaction that I've given on the board. Now, this is going to lead to the development of the concept of the mole. And of course, this particular aspect is an aspect that gives a particular package that contains a specific number of particles which are going to assist us to describe various quantities of gases and the reacting volumes of substances in chemical reactions. Now, a mole is basically a packet or a package that consists of a particular number of particles, which is 6.023 times 10. Of course, that is negative 1023 packets, so this is a positive value, or particles. And of course, this is going to be referred to as Avogadro's number. And in some literature, we're going to have this one given an initial of A. So therefore, whenever we come across this capital A, whenever we're talking about reacting volumes, then it refers to Avogadro's number, which is 6.023 times 1023 particles, which basically represents a packet that is referred to as 1 mole. So therefore, we can be able to put some conditions for these reacting volumes of temperature and pressure, whereby for gaseous mixtures or gaseous pure gases, then therefore at the standard temperature and pressure, we had mentioned the concept of a standard temperature and pressure, whereby we see that the standard temperature and pressure can be given in terms of that specific initials. And of course, we talked about the room temperature and pressure, and we're going to give those specific values, but the standard pressure is given in terms of 1 atmosphere, and of course the standard temperature, this is 25 degrees centigrade, and then therefore we're going to have those 2 specific values being considered whenever we're trying to talk about a specific variable. Now in this particular case, we're going to see that for gases at standard temperature and pressure, 1 mole of a gas in this particular state is going to contain a particular volume, which from experimental values has been attained, which is 22.441 liters. So whenever we talk about a reaction that is taking place under standard temperature and pressure, we're going to be bearing in mind that this basically refers to this specific concept of a volume. Now, any 1 mole of a gas sample then therefore is going to consist of this number of particles, as I've said. And of course, this is going to be applicable for all the gaseous mixtures or the pure gases that we're going to talk about, as we have said that we're going to treat gases in a general form. So therefore, of essence for us is to remember the relationship between volume and the number of molecules or the number of particles, which I've said that basically this forms the basis of Avogadro's law, whereby the volume of a gas at a constant temperature and pressure is directly proportional to the number of molecules given in this specific proportionality given as such. Therefore, we can develop an algebraic representation for this specific law given in terms of volume is equivalent to Km given as such. So later on, we're going to mention this specific, of course, particular formula for Avogadro's law, and this is going to assist us develop the concept of an ideal gas law as we go by for gases. So that is it for now, guys. By God bless you. Kindly check our description boxes for various links of other videos which are similar to this, and they will assist us understand this particular concept in a wider way. So that is it for now, guys. By God bless you. Catch us in our next video.